Hello there. So for today I will discuss with you examples, from subtopics kinematics of simple harmonic motion. So simple harmonic motion, short form we also can call it as SHM. Okay. So over here we have example 9.1 where you have an object execute simple harmonic motion where the displacement x varies with time t according to the relationship given over here. Where x is equivalent to 8 sine, in bracket 3 pi t plus pi over 2. So the x is given in centimeter and t is given in second. They wanted to determine the amplitude, frequency, period and phase constant of the motion for question A. For question B, the velocity and acceleration of the object at any time t. And then for C, the displacement, velocity and acceleration of the object when the time is given as 2 seconds. And then for D, the maximum speed and maximum acceleration of the object. So for question A. So for question A, what we can do is that we can compare the given equation with the standard equation. So by doing the comparison, we can obtain the amplitude, which will be equivalent to 8 cm. And then where the omega will be equivalent to 3 pi radian per second. And then we know that omega is equivalent to 2 pi f, so therefore we can conduct the calculation to determine the value of frequency. And once we have obtained the frequency, we can calculate the period, where the relationship f will be equivalent to 1 over period. So replace in to determine the period. So for the phase constant, this is also direct comparison, where the phase constant will be equivalent to pi over 2 radian. We just obtain from the equation only. It doesn't involve any calculation. For question B, in order to obtain velocity, we have to differentiate equation x with t. So that means dx over dt. So once we differentiate, we will end up with a omega. So previously a is given as 8. So 8 times omega, omega will be equivalent to 3 pi. Function of sine will become as function of cos. And then in bracket the value will remain omega t plus phi, which will be equivalent to phase constant. So further simplify, we will end up with the equation, where v will be equivalent to 24 pi function of cos 3 pi t plus with phase constant. And then to differentiate acceleration, we will differentiate velocity with time. So differentiating again, we have the initial a, multiply again with omega. So a omega, and then cos will become as a negative sign. So that's why you have a negative sign convention over here in front. And then in the bracket you will have omega t plus pi over 2. So expand the equation, so we will end up with the equation for acceleration. So this is a general equation for velocity and also acceleration. And for question C, they wanted to calculate the value when t is equivalent to 2 seconds. So this one we just replace in the value t as 2. And then we conduct the calculation. So over here the angle should be in radian. Make sure you use radian in your calculator, otherwise you won't be getting the answer. So since we also have the equation for velocity, just replace in the value t given, to determine the final answer. And then the same thing goes for the acceleration. So t is given as 2, determine the value of acceleration. okay, which will end up with 72 pi square or negative 711 cm per second square. Okay, so for the maximum speed we can utilize the equation for the maximum Vmax, okay, which will be equivalent to A omega. So just replace in the value of A and omega, so which will end up with 24 pi centimeter per second. Okay, and then for maximum acceleration, we will use the equation for A max, which will be omega square times A, so which will end up with 3 pi square times 8, which will end up with 72 pi square centimeter per. Okay, so for example 9.2, you have a body hanging from one end of a vertical spring. Perform a vertical simple harmonic motion. The distance between 2 points at which the speed of the body is 0 is 7.5 cm. Okay, so when we will have a speed will be 0 when it is oscillating up and down. Okay, try to think of that. Okay, if the time taken for the body to move between the 2 points is given as 0.17 second, they want you to determine the amplitude of the motion, frequency of the motion, maximum acceleration of the body in the motion. Okay, so for the amplitude, okay, we try to draw a diagram first. Now the object will be moving from negative A to positive A. So these 2 points you will have 0 velocity. Okay, so that means from negative A to positive A. Okay, and then the time given is 0.17. Okay, from negative A to positive A, and then therefore what we can do is that we can determine the amplitude by doing a division of 2 lah. Okay, because amplitude will be the maximum displacement from O to A. Okay, from equilibrium position to A. So divide by 2, which will end up with amplitude, okay, which will be 3.75. Okay, and then for the period, okay, so since moving negative A to positive A is only half of the oscillation, okay, and then once it return back to the negative A, you will get one complete oscillation. So that means just times with 2. Okay, 0.17 times with 2, you will end up with period, which will be 0.34 second. Okay, so once you have the period, we can calculate the frequency. Okay, where the frequency will be equivalent to 1 over period, which will end up with 2.94. And from the equation, maximum acceleration will be equivalent to A omega square. So just replace in the value, okay, which will end up with 12.8 meter per second square. Okay, so for example 9.3, you have an object of mass 450 gram oscillate from a vertically hanging light spring once every 0.55 second. The oscillation of the mass spring is started by being compressed 10 cm from the equilibrium position. Okay. Okay, over here they want you to write down the equation giving the object's displacement as a function of time. And then how long will the object take to get to the equilibrium position for the first time. And then for C, they want you to calculate the maximum speed and then the maximum acceleration. Okay, so to guide our problem solving, okay, information given is that we have mass and then the oscillation was given. Okay, so one complete oscillation, the time taken is 0.55 seconds, so that will be the period. Okay, so since you compress a spring which is hanging vertically, that means the starting or initial position will be positive amplitude. Okay, so you start with the positive amplitude of 10 cm. Okay, when time is given 0. Okay, so that means for this case you will have a initial phase. Okay, that means your graph will not start from 0. Okay, so amplitude is given as 10. Okay, and then from the period, what we can do is that we can calculate the angular frequency. Okay, and then the initial phase angle will be pi over 2 radian, okay, or which will be equivalent to quarter oscillation lah. Okay, so therefore final equation we will end up with tan sine, okay, omega t. So omega we already calculated 11.4, okay, plus pi over 2. Okay, or it also can be written in a function of cos, where is equivalent to x, okay, amplitude times cos omega t. Okay, so for the question B, at equilibrium position, displacement will become 0. Okay, so once we have the equation, what we can do is that we can replace in the value x is equivalent to 0. Okay, so and then what we do is that we simplify to find the value of t. Okay, so t, which will end up with 0.138 second. Okay, this is one method. Another one is that we know it makes a quarter oscillation. Okay, so quarter oscillation, so we have the period, just divide it by 4, so which you should be able to get equivalent answer also. Okay, and for question C, we just apply the equation for V max and A max. Okay, so by applying the equation, we will get the maximum velocity, which will be equivalent to 1.14 meter per second. And for acceleration, we will end up with 13 meter per second square. Example 9.4, you have an object, okay, of mass 50 gram connected to a spring with a force constant given 35 Newton per meter, oscillate on a horizontal frictionless surface with an amplitude given 4 centimeter. They wanted to determine total energy of the system, speed of the object when the position is 1 cm, and then C, kinetic and potential energy when the position is given as 3 cm. Okay, so for question A, total energy. So based on the information given, we have mass, K, spring constant, and also amplitude. Okay, we apply with the equation for total energy, which will be half Ka square. Just replace in the value, which will end up with the final answer, which is equivalent to 2.8 times 10 to the power of negative 2 joule. Okay, and for the speed of the object when displacement given as 1 centimeter. Okay, so this one we apply with the equation for velocity. Okay, omega is equivalent to root value of a square minus with x square. So we already have the value of omega, which will be equivalent to k over m. Okay, so replace in, then final answer, you will end up with 1.03. And for the kinetic energy, when x is given as 3 centimeter, apply the equation for kinetic energy. Okay, so since we already have the other values, okay, so replace in, and k will be equivalent to m omega square. So simplify that. So replace in the value, and k you will end up with 1.23, okay, times 10 to the power of negative 2 joule. And for the potential energy, okay, apply the equation for potential energy and replace the value x is equivalent to 3 centimeter, convert into meter SI unit. Okay, apply in, and then final answer should be able to get 1.58 times 10 to the power of negative 2 joule.